Okay, Shimon, thank you for introduction. Actually, Shimon already told everything what I just prepared as a story, how we just met and what is behind our project. So yeah, we do localization with IQRF. Not just planning to do it with IQRF, but okay, I will try to go in more details. Okay, my name is Milan Šimek. I'm CEO of the company, which is at the market 2.5 years, and we are sitting in Brno. And what actually we are doing is, I think there is common story of IQRF and of ours, because we are also producer of some kind of RF platform. But as IQRF using RF platform for communication, low power communication, we just design it and develop the RF platform not for communication but for localization and positioning. So our position in the business and our business model is to bring to our partners, vendors, and quite experienced partners the radio platform which they can integrate to their products and services to boost their own services with location intelligence, which is quite precise, which works indoor, and even to offer them with some kind of software platform, software visualization. So generally, our products are something what we call tech. Is the locator, is the small device which is placed on the object which we are monitoring, which we are tracking. Generally, when we are talking to customers, 50% of them have one common question: Can you locate the pallet? Can you locate people? Can you locate trolley? Can you locate my wife? This Wi-Fi is quite common. And still I'm answering, we are locating the black box, that's all. If you put the black box to your pocket of your wife, we are going to locate your wife. But still, in order to do localization, you need to have some kind of localization infrastructure in the facility. So the locator, the black box itself doesn't work. You need something like a GPS has satellite somewhere. And we just simply putting satellites in the ceiling in order to make it something what the GPS doing is, it's called time difference of arrival, just measuring the time of the communication of such two devices. And how we distinguish from another well-known radio technologies like RFID and the Wi-Fi and Bluetooth and all the techniques which rely on the measuring of the signal level is because we are measuring another parameter, and this parameter is what we measure and how we, for example, distinguish from for example RFID, because also customers are asking me, so it means that you have the transmitter, you have the receiver, and this is the tech, this is the reader, so this is RFID. And I am sorry, yeah, it's true, yeah, it's RFID, but it is RFID in the quite different spectrum, because our RFID communicates in the GHz band, and in addition to just making common identification, which we can do as well as RFID is also processing. We are adding one more feature, and it is the precise measuring of time of flight between the tech and the anchor. And if you imagine that you are able to precisely measure the flight of the signal, and you can process such information more times from more readers, you can do something which is quite known. It can be triangulation, multilateration, and all the techniques which are nowadays used in the GPS system. So just some technical info about the technology we are using. It's, as I already mentioned, we do not work with the IQRF for localization. We just considering use IQRF as the communication backhaul. I want to introduce our project behind our localization technology, one of them, where we are planning to use IQRF. But generally for localization we use another technology, which is also low power. It's standardized as a low power. In our terms, low power, it's as Vladia told in the morning, it's not extreme low power, it's not super low power, it is 100 milliamperes hours during receiving and transmission, but still it is defined like low power because it is the part of the standard AO2.15.4 where, for example, Zigbee belongs. But the amendment A means that this amendment A means that these standards on the physical level use absolutely different radio, and this radio is distinguished from another radios mostly with its frequency band, just channel bandwidth, which is about 20 times more, which is 20 times wider than common Wi-Fi or even Zigbee, because the bandwidth of technology, the general ultra-wideband technology, is 500 megahertz, and because of its cover quite wide spectrum, their transmission power must be kept as low as possible. Generally, the average transmission power we are quite happy to have minus 90 dBm. It's best what we can have. So if we are doing some analyzing and troubleshooting and on-site survey in the customer premises, and I see minus 90 dBm, it's the best what I can get, because after this wars and with these power levels we work. This is just comparison the channels, for example, Wi-Fi working in the 5 GHz. This is the networking picture, how technology is working. Consider that you have transmitters, which we call the tags, which needs to be battery powered. So they can be powered from their own batteries, or generally, if you are planning to localize the forklifts or logistic vehicles which operates in their own batteries or accumulators, you need just to have some 5 volts for powering of the tags. And as I already mentioned, you need to have some kind of anchors deployed in the facility, which measuring time of line during the communication, and simply processing such communication to the server, which is just only one who has some intelligence inside. The tags and the anchors are simply communication devices. The anchors are more, let's say, more clever than the tags, because it's just text that simply blinks in the regular manner, and the anchors needs just to synchronize itself. And such synchronization is also quite sophisticated task, which we did in our devices. So one of the key features what I didn't mention is our business model. As I mentioned in the first slide, we do not deliver the final solution. We cannot have solutions for all the applications which can exist for precise real-time location system, because I will show you all the application what we can do. So our business model is about to deliver partners and companies the tags and anchors and API, provide them with API, and just to serve them with the detailed support and 24/7 support in order to integrate the location data or location intelligence to their products, for example, to warehouse management systems, to fleet management systems, to another monitoring system which using, for example, RFID, or to make absolutely new product which using some kind of location intelligence. Sometimes we are telling that we are giving some more sense, new sense to the customer's product, and this sense is simply location data which are stored in the server are easily accessible through HTTP API. How does it work in practice? You can see at this slide. I already explained it. You have the objects you want to monitor. In this this is the forklift, where you just simply tag with the tag. It means you just put the tag on the moving forklift, and across the facility you install all the anchors. There are some rules for deploying. We have also some on-site survey tools how to deploy the anchors, because still those are just common readers of RF signal and even communicating in the GHz band. It means, yes, if you ask me, do you mind if there is a shelf or wall between the forklift and reader, I will answer absolutely. So if you have the shelf in the warehouse which is full of the products, for example tablets or laptops, there must be more anchors added, for example in the ASIL, which will have in the best direct line of sight to the tech, because still we are talking about the technology which works above 3 GHz radio. So all the data are processed by the server, which are in most of applications located in the customer premises, and no cloud solution till now was incurred by customers. So no customer was asking us if there is some API or solution, cloud solution, where he can store his data, because his data is quite sensitive and quite expensive, and all the customers want to store his data in his premises. So all the data are in the RTL server, and customer has its own application, or we provide him with the visualization and analyzing application which is able to analyze all the data. If we, for example, if we're talking with some customers and he asking us, so it means you do something like the monitoring and controlling people and all the vehicles in the factory, we generally answering what we do is the digitalization of the movement. It's for example, imagine that you have the set of the forklifts or set of the automatic guided vehicles. You have, for example, 100 of forklifts operating in your premises, and you come in the morning in your factory and you see, it seems that everything is fine because everybody is working. I see the forklifts coming from the left to right, and just cars are producing on the production line. And what we do is that we can digitalize this motion, so we can express this motion in the numbers. And if you know numbers, there is, just if what you can measure, you can optimize, you can measure, etc. So since we can measure the motion, you can optimize the motion. So that's our business. The indoor navigation and why this technology is, we believe, is quite promising, is also because of it's really the part of that so-called Industry 4.0, and lots of speakers and lots of presenters already mentioning that indoor navigation and indoor positioning is one of the key components and one of the key crucial players of coming Industry 4.0. So that's why I'm still going conferences and presenting about the Sewio Industry 4.0. What you can do with the indoor positioning, I already mentioned. You can go to the warehouse, you can go to the production facility, you can go to the automotive hall where lots of stuff is moving, and you can express this movement by numbers quite precisely, because what we can do, we can go to the 50 centimeters of precision, and we know how far forklift is from the human, or how far the forklift is from the automatic guided vehicle half year ago, for example, because it's stored in MySQL database. In retail, what we do generally, it's we follow the customers. We know how customers are behaving. We do not put the tag directly to the customers. We put the tag to the shopping trolleys and shopping carts. You have 200s, 300s of the trolleys, and we can simply show how the customers are behaving, how they are passing through the store, and how much they spend close to the chocolate, and what was the most often way when they visited 3 minutes around the chocolate shelves. And after a retailer can directly benefit from all the numbers, and the vendors or producers of the food can benefit from these numbers as well, because you can tell him that during the last month about 5,000 customers spent about 5 minutes watching his product, and those location data are quite interesting for any marketing activities. Talking about the sport, if you can locate, if you can monitor and tracking all the sport players and to show this number to the trainees. And for example, another activities we're doing is the laser games. Imagine that you can know all the statistics during your team building of your team, how many meters, who just passed, where he was hidden, and even you can show this statistic online, and you can show it to another customers who is coming there. And mini cart activities in Brno, what we are doing as well, is to again adding another new service to the service of our customer, just to show the trajectories of all the riders, to show who was when, just use this trajectory, and this location data just improve the service of our partners and customers. One of quite interesting project was in SKODA. It was in the cooperation. It was a project for SKODA Mladá Boleslav. The main partner of this project was Luka Logistics Solution from Poland, and this partner used our technology in order to put location data into the smart glasses. Why it is good for? I would like to show you some short video. I don't want to spend so much time on it. Just consider that you have seasonal workers just during, for example, the low Christmas time, when you have 100 brigades, 100 students, which should just only to simply take some boxes and put the boxes to the trolley, and you need to optimize, you need to reduce number of fails. Because those students or those workers are working just only during the season, and they have no experience where the product is, where to put the product, and what to do generally during the next step. So what is solution of our partner, powered by Sewio, is navigating people, seasonal people, what they should do. Yeah, somebody asked us, so it means that you are doing robots from the people. Not we, our partners is doing, we just help them. Okay, just because since I have just one more video, so I will stop it and we'll continue. So now I'm coming to that project who just merged activities of Sewio and IQRF. It is another project in another automotive hall, which I'm not going to mention here, and this project is about the completed automation and digitalization of the movement in the automotive facility. The goal is to digitalize all the movement in this facility, and if you are talking about digitalization, it's about the forklifts, automatic guided vehicles, those are the automatic trains going without drivers, and also the manually guided vehicles, which are operated by the people and people itself. Not just about the monitoring the performance of the people, but just in order to increase the safety at the place. So another video I would like to share with you is the result of such project, or just how this project is going to look like. It's this one. So this is the software, this is the product of a company called Edgecom. It's from Žilina, Slovakia, and they are just programming the guys, young guys, programming this. This is the software which can monitor the movement in the manufacturing. They are doing 3D, and they ask us that they need to monitor the movement. They need the location data of everything who is moving. So they can move with the forklift, they can move with the guided vehicle, and they can even store all the statistic data in the software. And the role of Sewio in this project is to provide them with the location data. So we are going to place the tech at the forklifts, guided vehicles, automatic guided vehicles, and manually guided vehicles, to provide our partner with the precise location data in order to benefit from such software, just to boost this software for the automotive hall. And at the end, once the pilot will be proved, this should be the result after 2 years of the project. We are preparing the navigation panel for the forklifts, which should help the drivers to navigate across the facility. So the result of such project is also the navigation for the drivers. So here is coming the technical question and the issue what I just tried to decide to go with IQRF, but still I need to do lots of proof of concept and tests. This is the one hall where we are planning the pilot project in that automotive hall, in the industry. The number of the readers which we just suggested for such project is about 50. The green spots are all the ultra-wideband readers of Sewio. What we need to do right now is to interconnect all the readers. And right now just coming the quite big challenge, because just common solution is this one, what we generally use in the retail, in the sport, and in the most of the warehouses. But here's the cables cannot be considered because of quite expensive infrastructure, quite expensive the cost of the people who are going to install, and the cable cannot be considered for many reasons. So cable cannot be. So solution second is to substitute the cables with the Wi-Fi. It means just to take the anchor, take the reader, and just put there some converter which just put out the cable and send all the data to the local Wi-Fi, because in such automotive hall or manufacturer you cannot install your own device, Wi-Fi devices, because it must be controlled by the IT department. So we decided, okay, we just hooked out all the cables, and we replaced the cables with the external converter, Wi-Fi connector, because Wi-Fi works. Everybody believe it. Everybody knows how Wi-Fi works. But the two problems is the lots of Wi-Fi converters just considerably increase the price of all the readers. The challenge number one. Challenge number two, that the local Wi-Fi is not just only for Sewio. Local Wi-Fi is for lots of other services operating in that facility, and the operator can't guarantee the throughput, latency, jitter, nothing. So just if the Wi-Fi is overloaded by another services, your quality of service is going to be forget. So the Wi-Fi cannot be used as well. So that's why I was calling Shimon 1 month ago when I just was traveling to the automotive hall, asking what to do that cables cannot be used. Wi-Fi is no solution as well. If we can consider to use IQRF as the replacement of the cables and the Wi-Fi, it means to build quite new solution which we can infrastructure-less readers. It means without any Wi-Fi, without cabling, just to power up all the anchors and using such power to power our readers and also IQRF modules. So here we started to work on it, just work on this idea, just not to work on it with hardware, because right now we're just preparing some tests. But from this picture you can see all the benefits which can imply from this cooperation. I mean Sewio anchors, IQRF modules, which passing all the data to the IQRF gateway, which is connected to the switch of the automotive hall and to the Sewio RTLS. But there are some challenges which need to be considered before going to the pilot, and this is the requirements of such pilot, which is about the monitoring 60 vehicles with the refresh rate, I mean every 500 milliseconds, with the precision of 50 centimeters. Precision is fine, refresh time 500 milliseconds is generally fine, but is it fine for IQRF? It needs to be considered. It's a big challenge, because if we pass the pilot, we need to consider that in the future, since once you have the infrastructure, you can easily scale by adding more techs, for example, 2 people to save them against the injuries, against the collision with the forklifts, and even if the customer will decide to go with more vehicles in the facility, are we able to manage it with the IQRF big hole? So when we just consider all the throughputs and just numbers, we just calculated that all 60 vehicles in the facility will generate about 80 kilobit per second as total. It means just every second we need big hole which is capable enough to manage 81 kilobit per second. Maybe we can do it. There is in data sheet 20 kilobit per second, but we need to consider that this throughput is going to be loaded all over the facilities, so maybe we can handle it. But if we want to even to control the devices, for example, to stop vehicle in some position, so we need to also talk back to the vehicle, and we need to do it in the hundreds of milliseconds. So after we need to consider if we are able to use this big hole for communication. And also interferences needs to be considered for any other projects. So our next steps is to go with a test to build up such network with the 50 modules, and to evaluate with our technology the latency and the jitter, because jitter is quite important for the real-time monitoring, and to focus on the really high reliability of such technology, of such solution, because if we fail in the automotive we have some penalties for it. It's not so easy as work in the smart house. Smart is also perfect, but here we need to be really sure that this technology we can rely on. So I didn't mention anything about the company. And this is I just using this slide, something like to prove that the indoor positioning has really the future, because we have some small success with the business in it, because we set up the company after we got some experiences in the indoor positioning from 2011. We've been me and Lubos, my friend, and we met at the university. And after 2 years, we decided to set up the company in Brno. It's called Sewio. It means sensor wireless. And within 1 year, we sell the company, just part of the company, to the investor. Just got some funding, and within 2 years after setting up that startup, it's quite a sexy name for a young company. Right now we are 12 and hope we grow in the team manner, because till now we sold our platform into 33 countries all over the world. If you are interested in the references, go to website, you can check them. And also we have our own assembly line, and we are quite happy for that. Thank you for watching, and see you next time.